I want to just show you a few more things where we're going now and how we're trying to put these pieces together. This is a discovery emerging in real time, and I have a few new images hot out of the lab. This is a zinc spark occurring in real time, or in about 10x speed, but we now are looking at it in 3 dimensions. We put Emily's probe inside the cell, a beautiful green color. We put the other probe, which is red, outside the cell. The 2 probes don't mix with one another. But what you can see is the cell lights up, and you see that the zinc sparks occur as these yellow flashes, almost like sunspots. And then as the brightness fades inside, what you'll see and the yellow comes in, that's an overlap of the red and the green. Then you see the red spark moving away from the cell. So we've literally caught it in flagrante. We've caught the event that the sperm introduces perhaps the most fundamental change in physiology of the egg, that now sends information careening throughout the cell and announces that we have to change our game plan. After all, the cell was dormant for sometimes up to 40 years, and now it has to completely retool. I've just slowed this movie down for you. You'll see these yellow spots. Those are individual compartments or groups of compartments releasing their zinc, and when it's yellow, then the 2 probes are intermixing a bit, and then when it's red, it's just outside the cell. And so you can literally see this spark move. The last bit of data that I want to show you that is just has our jaws dropping, and it literally opens completely new ways of thinking about cell signaling, is what we call a zinc wave. Now, these are cells that Emily inserted the zinc probe, the very sensitive one, and then put the red one outside the cell. They've been fertilized, and about 10 minutes later, they start to show the spark. So you see the red emerge, that's the spark, but now we can watch the trafficking and the communication. What's the zinc doing inside the cell? What you'll see in every one of these cases, when you see a zinc spark event, you'll see a zinc wave that moves slowly, much more slowly, as kind of a C shape until the cell now becomes completely covered in the green dye. So watch this cell right here. You'll see this wave of zinc moving in. Here's a very bright one. Every one of these eggs did this, and now this would be the slow signal, we think. Could be the master switch that tells which classes of proteins now to begin communicating with other groups through these other signaling pathways that I've shown.